This video covers Module 3, Part 2, which covers systems of linear equations and how to solve them using elimination. The previous video covered substitution. This video, make sure when you complete it, you're completing those guided notes. And elimination is the next method that we're going to have in our toolbox to solve these systems of equations. So elimination, the main goal of elimination is to eliminate a variable. So let's take a look at these two linear equations. I have 3x minus 4y is 11, and negative 3x plus 2y is negative 7. One thing we might notice is that our x terms are opposites or additive inverses, meaning if we added them together, we would cancel out those terms. So if I had 3x minus 4y is 11, and negative 3x plus 2y is negative 7, if I added these two equations together, my x's would go away. I would have negative 2y is a positive 4, and I could solve for y is 2. Now, much like with substitution, we could plug this back in to either equation and solve for x. And the key step to solve a system of equations by elimination is to make sure that two of your variables are additive opposites so that you can add them and they will cancel out. They'll go away to 0, like we did here. This gave us 0x. So the steps specifically are, what we want to do is multiply one or both equations by a number in order to get one variable that differs only in sign, i.e. those are additive inverses. You might have heard that before, or opposites. For example, maybe 5 and negative 5 would be good examples. Why do I always pick 5? My 5s never look so nice. There. Then what you do is add your new equations together. This will result in one variable from the equation remaining. If it doesn't, double check your math, or you may have multiplied by a wrong number and you can start over to fix this. We then solve for the remaining variable and substitute that back into either equation to solve for the other variable. And as always, we want to write our answers as an ordered pair. So let's solve a few examples and an application. So for this first example, I have 3x minus 4y equals 11 and negative 3x plus 2y equals negative 7. This is the example from the previous slide. So when I added those together, because my x's cancel out, I found that negative 2y is 4. I divide both sides by negative 2 and found that y is negative 2. Now I can plug this back into either equation. I'm going to choose the top one. And I can plug in negative 2 for y to solve for my x. 3x plus 8 is 11. I subtract 8 from both sides. 3x is 3, so x is 1. My ordered pair, where these two lines intersect, is when x is 1 and y is negative 2. And you might be wondering, okay, this is how we solve them by elimination. We also learned substitution. Well, you get to pick. On your homework, it typically will suggest to solve something by elimination or substitution. I recommend doing the method it says, because on things like exams or checkpoints, I'm going to want to see that you know both methods. But pick which one kind of feels the best. If you've got a variable already by itself, substitution. If you don't, elimination. So here I have x plus y is 5 and x minus y equals 6. I can already see that my y terms their coefficients are additive inverses. This is like saying I have 1x and negative 1x. So if I add these together, I'm going to have 2x equals 11. Now, when I divide by 2, I get a fraction. So x is 5.5 or 11 halves. And it's okay to get a fraction. We know how to work with these. So now I can substitute 5.5 5.5 into either equation. I'm going to pick the top one. So I have x plus y is 5. So now I have 5.5 plus y is 5. I subtract 5.5 from both sides, and I find that y equals a negative 0.5 or a negative 1/2. So I can write our answer as an ordered pair, either in fraction or decimal form, but I know that x is 5.5 and y is negative 0.5. For our third example, we are also going to solve this using elimination. But in this case, we don't already have two coefficients that are opposites. I've got 3x minus y is 11 and 2x plus 5y is 13. So I look for what would be the easiest two variables to cancel out. If I wanted to cancel out the x, I would have to multiply the top by negative 2 and the bottom by a positive 3 so that my x's both were 6. But for y, I can just multiply the top equation by 5. And remember, what I do the left, I have to do the right. So I've got 15x minus 5y is 55. And my original equation, the second one, which was 2x plus 5y equals 13. Now those coefficients are additive inverses, so when I add them together, they cancel out. That gives me 17x is 68, so x is going to be 4. I can then substitute that into either equation to solve for y. So I've got 3x minus y is 11. Let's substitute in 4. 3 times 4 minus y is 11. 12 minus y is 11. I subtract 12 from both sides. Negative y is negative 1. So y is 1. This ordered pair would be when I have x to be 4 and y to be 1. Our last example before we look at an application is 4x minus 3y is 0 and a negative 10x plus 7y is negative 2. So here I don't have either of my coefficients for my x's or my y's being additive opposites, and there's no way to multiply a 3 to get a 7. There's no way to multiply a negative 10 to get a 4. So what I'm going to have to do is multiply both equations by a different number. So I'm going to focus on canceling out the y's. I'm going to multiply this top equation by 7. That'll give me 28x minus 21y is 0. And this bottom equation by 3. So my y's will both have a leading coefficient of 21. I've got negative 30x plus 21y is negative 6. I can then go ahead and add these together because my y coefficients cancel out. I have negative 2x is negative 6, so x is going to be a positive 3. I can substitute that into either equation. I'm going to pick the top one because it's just a habit. 4 times x minus 3y is 0. 4 times 3 minus 3y is 0. 12 minus 3y is 0. I move my constant to the other side and find that y is 4. So the solution is when x is 3, y is 4. Our application that I want us to solve using elimination is as follows. So tickets to a school play cost $12 for adults and $8 for students. If 600 tickets were sold and the total sales were $5,516, how many adult tickets were sold and how many student tickets were sold? So I'm going to use A for adult and S for students. And I actually don't like using S as a variable because it looks too much like a 5. So why don't we use C for like children? And I know not all students are children, but it's what we're going to use in this case. So A is for my adult tickets and C is for my student tickets. So I have A plus C is 600 because A and C are the number of tickets, not the value, just the number of tickets. I don't know why that's not writing very well. There we go. The number of tickets. I also know that if I sold all my adult tickets for $12 and all my student tickets for $6, that's going to add up to $5,516. So to solve this for elimination, I'm definitely going to have to multiply the top. Oh, it's not 6, it's 8. So sorry, $8. So I'm definitely have to multiply this top equation. I can multiply it by either negative 12 to cancel out the A's or negative 8 to cancel out the C's. I'm going to pick negative 8 because I think the smaller number less likely to make a mathematical error. That gives me negative 8A minus 8C is negative 4,800. And I still have my original equation of 12A plus 8C is 5,516. I add these together to get 4A is 716, which means A is 179. So I had sold 179 adult tickets. My original equation that I had was A plus C is 600. So I can substitute in what we found, that 179 for adult. So I have 179 plus C is 600. That tells me that the number of children's or students' tickets was 421 student tickets.